Do you ever wonder where your old Nokia or Motorola went? Chances are it ended up as e-waste. Discarded electronics no longer capable to keep up with our demand of having the next best thing. This includes old TVs, printers, copiers, computers, monitors, and the list goes on and on. In fact, e-waste is the fastest growing category of municipal waste and constitutes for about 9.4 million tons annually in the US alone. On average, that's about 66 pounds per person. While devices have improved, the way to dispose of them hasn't. Instead of recycling electronics here in the US, they are almost always shipped to developing countries to be picked apart for their precious metals. This process first started in the early 90s when the volume of waste was growing so fast that the recycling plants could only get to a fraction of the electronics. As an alternative, the e-waste was packaged and shipped to developing countries like China, India, and Africa. These countries didn't have the laws protecting the workers or environment from the hazardous materials. The problem of e-waste still remains, with more recycling sites popping up all over China, India, Pakistan, and Africa. However, recent laws have prohibited shipping broken electronics, e-waste, to these countries. Yet it is legal to ship working electronics. So to bypass this, broken electronics are shipped and stated to be functional. Rather than recycling the materials themselves, companies send the problem somewhere else. In the US and other developed countries, real wages and environmental standards must be taken into consideration when recycling e-waste. While in China, for example, the laws are much more relaxed and wages are close to nothing. Companies that ship e-waste to other countries avoid the heavy cost of recycling while also turning a profit. Because companies are paid for each container of e-waste, it's a lucrative business. It is estimated that half of the electronics in the US find their way to developing countries. The pay that comes from scrapping up precious metals is often much better than if they worked elsewhere. Computer chips and motherboards contain metals like gold and palladium. Therefore, recycling is almost seen as a business opportunity to people in developing countries. The average pay for picking apart e-waste for copper, aluminum, plastics, and other metals is only $1.50 per day. But what may seem like good pay for them is outweighed by the drawbacks. Many children who live in these e-waste areas sort through the old monitors, printers, and computers have blood lead levels over the limit here in the US. In Guayu, China, over 82% of the children have blood lead levels over what is considered safe. Soil in these electronic graveyards contains lead, cadmium, arsenic, and mercury in dangerously high amounts. A village in Guayu, China, a former farming town, is now the largest recycling center for e-waste. It boasts some of the most polluted soil, air, and water in the world. The soil was tested to reveal that it had levels of lead over 200 times that deemed hazardous by the national government. The water was found out to contain lead 2,400 times that of the World Health Organization's limit, and the water is so acidic that it has the ability to disintegrate a penny in a few hours. Legitimate recycling companies are being created all over the U.S. A map shows the amount of recycling centers in the U.S. approved by the EPA, and the number is only expected to rise. When properly recycled, electronics do much less harm to the environment, and also provide the recycler with a profit from the materials. Gold can be captured in high amounts from the computer processors, while silver is collected from the motherboards.
Other parts of a computer's interior are a lot harder to recycle since they contain a mix of metals, but the effort is still well worthwhile. The metal parts are stripped down and put into a furnace. They melt into a liquid mix of gold, silver and copper, which is poured out, cooled, pressed, and then sliced into plates. Each plate is placed into a bath and given a positive charge. Here we see it on the left. On the right, a negative charged copper plate attracts the copper particles, which loosen from the mixed metal plate and accumulate there. In the next bath, a steel plate attracts the silver, which forms in crystals. After the second bath, the plate contains nothing but gold and can be melted down. It will be shaped into different forms that have a variety of uses.